Good morning. So today's lesson is going to be covering lumber types, different uses that we can have for them, some of the defects that we'll typically see, the joints that we can make with them, platforms, and walls. Now, to begin, we're going to talk about sort of the two main types, such as softwood or hardwood. Softwood is basically from the conifer tree, or also known as sort of pine, fir, or spruce. It is the easiest to work with across just a wide range of applications. And this basically means that it's the most effective in sort of your general everyday building purposes, which makes it great for theater. That it grows pretty fast and it tends to be cheaper makes it also ideal for just about every kind of construction project. Hardwood, on the other hand, is a little denser than your softwood material, and some of the different types that you'll typically see are birch, elm, mahogany, oak, or walnut. Now, obviously, there's a lot more different types of hardwood. Those are just some of the general ones. Now, with hardwoods, they'll definitely be a lot more pricier when it comes to purchasing, depending on how much you need, and just sort of availability for where you are located. Hardwood is typically used for sort of finished work. You'll see it a lot of sort of furniture projects or sort of decorative things, which doesn't mean that you can't necessarily do that with softwoods, but obviously with the hardwood types, the veneer or the top layer or the wood grain that you see makes it substantially better and obviously a little prettier to get a final product. There are a few other types that aren't really directly made of wood, such as MDF or PVC, and that's generally just sort of depending on what kind of project you need to work on. MDF we'll cover a little bit later, but PVC is basically sort of like a plastic, and it is pretty easy to paint with. It's a pretty smooth surface and almost looks identical to a wood finished product unless you really look down and try to look for the differences. So with that, we're going to first talk about what is known as dimensional lumber. As we just mentioned before, softwoods are usually the ones that we will see or use in theater, and the most common type that you'll see is either white pine or yellow pine, and again, both have pretty similar characteristics. Yellow pine will be a little darker and a little more denser than white pine as it was. Now, dimensional lumber basically refers to sort of the name of the board type that you're working with. And it refers to the actual dimensions of that particular board. Now, the dimensions are referring to the actual sort of side view, as you can sort of see here. So if you were to look right at the edge of the board, your 2x4 or your 1x4 is what it's known as nominally, but the dimensional side actually refers to the actual measurements of that board. So 2x4 is not actually 2 inches by 4 inches, but is actually 1.5 inches by 3.5 inches. And then 1x4 is actually 3/4 of an inch by 3.5. Funny little side note, anyone who hasn't maybe known this, there actually have been a couple lawsuits against some of the main or major distributors such as Lowe's or Home Depot regarding the fact that the difference between the dimensional lumber and what is nominally known as caused quite a bit of confusion in some people's home projects. They assumed that the actual 2x4 measured 2 inches by 4 inches and built or bought according to those dimensions. Needless to say, they won, and now in most of these sort of hardware stores, you'll actually get the nominal name, such as 2x4, and then actually have the dimensional numbers right next to it. Now, these are basically just referring to the two most commonly used types of lumber. There are other types, such as timbers, as shown here. These are, as when we cover sort of the how everything is cut from lumber or logs, you'll see sort of the spiral pattern or the circular pattern on the end of those timber pieces. Those basically mean that they were cut from the dead center of most trees. And one of the reasons for this is just because it gives you a lot more sort of structure and integrity when using those particular types of timber. Another type that you may or may not see are known as sort of little furring strips. And these typically are about sort of the size of your 1x pieces, but they'll generally be a little bit smaller. And these furring strips are basically just used as sort of a way to help sort of level out some types of projects to give you a nice, flat, even surface. Plywood has a lot of different sort of grades, as it were, and those grades all sort of depend on what the exterior or the outer layer is designated as. The veneer grades for sheet materials are as follow. In or natural finish veneer are all heartwood or sapwood and usually free of all defects or open defects. A is a smooth and paintable with neatly made repairs, also used for natural finish in less demanding applications. B, it is a solid surface veneer with circular repair plugs and tight knots. That typically means if there's any kind of sort of opening in that particular veneer layer, it'll get filled in as needed. C, plugged. It's improved C veneers with splits limited to 1/8 inch in width, knot holes and borer holes limited to 1/4 inch by 1/2 inch. C, knot holes to 1 inch, occasionally knot holes 1/2 inch larger, permitted providing total width of all knots within a specified section does not exceed certain limits. Limited splits permitted, minimum veneer permitted, and exterior type plywoods. Or D, permits knots 2.5 inches or larger under certain specified limits, and limited splits permitted. Obviously, as you sort of go down in grades, the overall finish is a lot rougher, and that's usually why with grading, you'll typically have two of these combinations, and they sort of have various uses. Grade AA is usually the top end that you can get, and it's mainly for interior uses such as cabinets, cabinet doors, furniture, where you'll typically see both sides. So obviously the top and the bottom layer both have the sort of highest quality veneer showing. AB is another pretty useful type. It has not as many defects as the A, or it has a few different defects, but it still has a pretty high quality look and view for it, and it is usually only used when only one side is to be seen, even though the B side could be seen if needed. AC is sort of similar to AB. You'll typically only have the A side sort of facing out, whereas the C side is more of just sort of the layer that you'll have underneath or facing down. AD, or usually ply panel, their uses sort of include lesser quality wall paneling and cabinets. It's a pretty good all-purpose, good one-sided sheet. BD is sort of your construction sort of go-to It can be used again in sort of the lower substitute for sort of the AB paneling, um, as long as it's painted. CD is sort of your generic sub flooring that you'll typically see in housing or construction. And it's great sort of as a base for tile work, linoleum work, or carpeting. There are again sort of the same grading systems except for exterior plywood. We won't go to the specifics, but no, they're roughly about the same as far as everything goes. The most sort of common type, again, used if you've ever seen or driven by a house being constructed, you'll typically see as the frame of the house goes up, they'll start to attach plywood, and that'll typically be sort of CDX or AC plywood, sort of depending on what they need. And with at least CDX is a really common and inexpensive exterior plywood, where X denotes the exterior glue. There are some hardwood plywoods. We typically don't see them in theater as often, but they do exist. Luan, on the other hand, since it is a fairly thin sheet, it typically will be used only as an underlayment if used with another fairly structural form, such as like the CDX plywood of fairly thick purpose. And then sort of the Luan could be added as just sort of an extra piece or just sort of help level anything out. You'll typically see Luan used in theater, though, as sort of a wall purpose. It's great for a lot of the construction that we'll end up seeing later on in the semester. But another form of Luan is known as sort of the bending Luan or bending board or wigglewood. And this sort of sheet good allows sort of the particles to sort of bend freely. Whereas instead of having something that's fairly rigid and sturdy, this bending board allows you to sort of warp around or manipulate it in such a way to sort of help create some of those curved surfaces or curved pieces that we'll discuss a little later. MDF, as we sort of briefly talked about, is great for sort of cabinetry work. A lot of the interior pieces of cabinetries will be made from MDF, as it provides a really nice smooth surface and a pretty good finish, especially whenever painted and or sealed. Masonite, or also known as hardboard or pressboard, is again sort of that compressed wood pulp, available in sort of tempered dark brown hard surface, and untempered sort of a light brown softer surface. It's great for sort of curved surfaces and decking. Depending on sort of the theater that you go into or you're around, you may have the floor actually be made of this masonite, as it's pretty easy to lay down, and it provides a pretty flat surface to work upon, but is not slick, such as MDF. Some floors can be made from MDF. It really just depends on the preference of that particular company. OSB, because of the flakes in each layer are aligned in a direction sort of 90 degrees from the adjacent layer, OSB has superior bending qualities to sort of its counterparts, sort of waterboard or particle board. But it's again sort of used as sort of a substructure piece. You typically won't see it in sort of the main frame or sort of the sheet good used to hold some framing together, but you'll see it in conjunction most often with other pieces or other parts such as plywood. When it comes to lumber, as we sort of briefly discussed, you're going to come across certain defects that just come naturally in how the piece is cut. We sort of briefly talked about how plywood has sort of knots or holes cut into it, and depending on the grade that is that particular sheet good, they'll either be filled in or left open. Now, those particular defects come from sort of the process in which they are cut, and those openings or knot holes are basically from the tree branches that may have been growing from that particular tree, but once it was cut down, that tree branch obviously just didn't exist. Whereas during the blade cutting, it'll basically still have that sort of hard knot form remaining in the lumber. Here you can typically see the most commonly seen defects when it comes to sort of the dimensional lumber. Depending on sort of the grade, you'll typically either see the knot go partially from one side tapering down. You'll see them either go all the way through, or depending on sort of the drying process or expansion due to moisture, humidity, that the knot may just have fallen out altogether. Versus some of these other ones where, depending on how the piece was cut, you may have the knot stretch from one side to almost the entirety of the board width. Or most commonly, you'll see that the knot actually goes all the way through, such as that middle section there. Or you'll just have it barely visible from one side or the other. Now, depending on sort of what board you have and what type of knot that you have, you'll most likely want to make sure that it is structurally sound, and that whenever you sort of pick it up or are working with it, that piece doesn't accidentally crack or fall apart due to that knot reducing the overall structural integrity of that board. If you do happen to run across any of these, obviously it is best to try to cut it completely out and avoid them altogether, but there are some times in which that it can be unavoidable, and you may have to form a special kind of joint, which we will cover a little later in this section. Now, while the knots can form some of the more noticeable defects in lumber, there are actually quite a few other defects that can happen just due to natural processes or how the lumber is stored and kept, or how it was eventually dried. Checking or splitting is basically when the end of the board starts to crack sort of in line with sort of the grain of the wood. It's usually most notably happens if sort of the center dried out a little slower than the ends, and just due to either kind of pressure being put upon that piece or not enough pressure, it wasn't able to sort of hold together. Cupping, on the other hand, is again sort of a natural thing that happens in the drying process, in which the board itself starts to sort of curve along the length of the cut, as it were, and that usually happens if it's trying to follow sort of the natural ring or shape of the tree that it used to be a part of. So you'll typically see in cupping situations where the wood grain on the end is starting to curve up, sort of in line or with sort of the cupping that is existing or happening. Waning is pretty common to see, and that's basically where a corner or an edge of a board seems to be sort of tapered or cut away. Or you'll typically see a lot of sort of darker spots in those situations. And that is basically when the board that had been cut was really close or right on the edge, and the waning is basically the part of the bark that may have just not been fully cut off, just due to how that board was specifically cut to make sure that it was whatever nominal size that they wanted. But it's not something that can be sort of detrimental in a building process, and we'll sort of cover how to deal with waning when we get to sort of the framing section. Warping is sort of another or difficult piece to sort of deal with, also sort of known as twist. And that's basically where the board just does or has a mind of its own. Um, and that is usually when, in the sort of drying process, there isn't enough weight to sort of keep it down as it's sort of drying, and sort of the pressure doesn't allow it to sort of maintain its actual shape. Twists, it basically sort of just takes one end and the other and twists it like you would sort of wringing out a towel. These are probably the most difficult pieces to use, and they'll generally only happen on like a few feet of a long board. But if it happens to go throughout the entire board, you'll ideally want to try to cut it down into as many small pieces to try to help sort of flatten it out as best as possible. Two of the other ways that some of the defects can occur are known as sort of bowing or bend. Now, they are very similar, except for the fact of sort of the orientation of the board as it is happening. Bowing is when the board is completely flat on face, and the ends either start to cup up or down, depending on sort of how you have that board oriented. It's basically no longer completely flat, as if it were just sort of to sit on the floor and be completely touching at all points. Bend, however, is when the board is on edge and the two ends again sort of curl up or down, depending on how you have the board oriented. Depending on sort of how you have these defects sort of presented to you, there's a couple things that you'll sort of have to try to sort of help alleviate those problems. Bow would not necessarily affect the overall interior structure of a piece, and therefore could be utilized as much as possible and sort of remain fairly safe to use. If it happened to be on a board that's on the edge of a framing piece, and we'll sort of go over this momentarily as well, you'll typically have to try to bend it or push it to sort of help fit within sort of the guideline of the sheet good that you're going to eventually attach to it. Bends, however, are probably, again, one of the more difficult defects that you'll typically run into to use, as the board doesn't want to maintain its actual shape. If you try to use any kind of bend in the board, it's going to dramatically alter the overall structural shape of your project. While I'm going to leave some videos to show for Thursday for all of you, I am going to briefly describe sort of how all of these dimensional lumber pieces and sheet goods are actually made. Here you can sort of see the methods of sawing lumber. These are sort of the four most commonly used types, and sort of they each sort of serve their own purpose. The sort of triple cut quarter sawing is sort of the most economical and tries to get as much from the material as possible. The alternating quarter sawing, again, sort of tries to get as much from the material as possible, but not being as efficient. Common quarter sawing is probably the most used, as it doesn't require a lot of different cuts with the machines. It typically will just take layer after layer after layer, cutting sort of from the top down to the bottom. The radial quarter sawing, however, is probably the best quality type of lumber, as with the grain of the wood being almost in line with the boards that are cut, it allows sort of the least amount of defects to actually form or happen. And then here you can sort of see how plywood is made, and it's basically how a log is sort of rolled or spun close to a blade, a stationary blade, and that blade will basically cut away whatever thickness is desired or chosen, and it'll just basically create that sort of veneer sheet. And as those veneer sheets are sort of cut, processed, and dried out, they are then alternated to sort of create the various layers of plywood. Here you can sort of see the top ply versus the second layer, which has the grain going in the opposite direction, and then back to a vertical, and then back to horizontal, and then back to vertical as the bottom sheet. Now, obviously, depending on how many layers, you'll either have more or less, but it all depends on the overall thickness of the material. As plywood goes, it can range anywhere from a 1/4 inch thick all the way up to most commonly seen 3/4. But you can sort of custom order some pieces that can be substantially thicker if so need be. And that is usually where you'll get anywhere from 3 to about 7 layers, depending on the overall thickness of the material. Moving on to joints, we're going to start with the most commonly used, and that is known as the butt joint. It is the easiest to work with, and it's simply just putting two boards next to each other, as sort of seen in the picture here. It's the most commonly used in construction, and of course, any sort of skill level should be able to work with this type of joint. To fasten this joint together, you would typically use screws and or nails from pneumatics to attach the two boards together. When we get to the framework of pieces, this is the typical joint that you'll see used. Miter joint, as you could remember, is basically where the edge of the material is cut in such a way that it sort of creates an angled piece. And that allows sort of the two pieces to then be put next to each other. And what this allows you to do, or what it does, is it removes the end grain of the wood, and it gives you a pretty clean corner. How to attach these sort of depends on what you have available and what the finished product is supposed to look like. Most commonly used is having the joint done and then using some sort of wide crown stapler or corrugated fastener to attach on one side only, because you'll want the other side looking pretty nice and it be the finished product. To ensure that everything is held together. Otherwise, you can bore some holes into the material and attach or install dowel rods, or you can cut a little bit of the corner out and create add what is known as a spline, which is then glued and clamped, and once it is all dried, creates a pretty nice joint. One of the others is known as a rabbet joint. And a rabbet joint basically just means that part of the material has been removed, and then a secondary piece or the second board is then sort of placed within that sort of little slot. There are many forms of the rabbet joint as shown here. And it is mainly to allow you to sort of put some sort of backboard onto a case piece, or to accommodate sort of a glass in a mirror frame. The dado, or housed dado, is basically where part of the material is removed from sort of the middle of the board, and then the secondary board is sort of slotted into it. This particular method is great for sort of attaching shelves to a bookcase, and typically whenever used with sort of the rabbet, also known as sort of the rabbet dado, it can be a really strong joint as sort of it stands alone, which wouldn't require any fasteners at all. Some of the other fancier joints that we can come across, one is known as the mitered rabbet. It is basically sort of a combination of the miter with the rabbet joint itself. It again is just a little bit of a nicer way to sort of create a sort of specialized joint and creates a pretty nice look whenever it is finished. There are some more intricate ones as well, shown here, the stopped dado, and that basically sort of creates a small channel within the board itself, which allows a secondary piece to slot into it. It has its sort of unique uses. It can sort of create the illusion of a really nice joint without having to show exactly how the joint was made. And sort of just however you want to look at it. Some of the other joints are known as sort of the mortise and tenon, and that's basically where most of the material from one board is completely removed, which sort of creates a little tongue or a little peg, and that little joint will slot into sort of the mortise and sort of create a really strong joint if used in conjunction with a fastener or a dowel rod that sort of slots between or through that mortise joint and goes through the tenon as well. These will typically be seen in sort of sometimes leg additions to tables as it provides a pretty strong joint, but then allows you to change it out with a little bit of brute force later down the line, or easy to replace. The half lap is basically where, again, sort of some of the material is taken out, and then that allows sort of another piece to sort of be attached directly on top of it. The half lap basically allows both boards to remain on the same plane, so you don't have any sort of excess thickness added to that particular project. It's mainly used in sort of cabinetry work, drawers, and it can be sort of an alternative to the butt joint on its face. The scarf joint is where a miter is cut along the edge of both pieces, and then again it sort of allows you to sort of remain on that same plane. The difference here with the scarf joint is the scarf joint is used to basically extend the two boards in case you weren't able to have a piece long enough to begin with. As most lumber types come in sort of standard or nominal sizes, there may come a time in which a project requires you to build something much larger. The scarf joint would be the joint that you would want to use in order to extend those boards and keep everything together. This particular image here is sort of the preferred method, as it gives or provides a lot of surface area for the two boards to basically be touching one another. You'll typically have to have what is known as sort of a scab added to either side, as shown here, to ensure that that joint stays together through the build process. One of the other fancier joints that you could maybe come across in your everyday life is known as the dovetail. It is used in mainly box construction, such as drawers or jewelry boxes, sometimes cabinets, or other pieces of furniture where strength is desired. Once glued, and again, this is another one that doesn't require any type of fastener to be added to it, it is almost an indestructible joint. And then here are just a couple images of some of the other types of laps, or different types that we've already discussed, and some of the variations that sort of come with them. Now, depending on sort of what materials you're working with, or sort of what type of joint you're looking to do, Obviously, there is a little bit of skill level that is required in order to assemble some of these projects. There is also even some specialty tools that would be required to create some of those joints. Now, the advantages, obviously, of doing some of those specialty joints would be sort of the increased strength, which makes them long lasting, or it could be sort of a decorative piece, and they sort of resist a lot of forces pretty well. However, they can be, again, sort of very time consuming, um, such as just the amount of time that it would take to hand cut a lot of those joints, especially in the dovetail. Would require a lot of patience when it comes to working with that particular joint. Now, there are some specialty tools that do expedite that process, but they aren't sort of commonly seen in most scene shops. So if this is a joint that you were looking to do, you would most likely have to spend not a major fortune, but a decent bit of money in order to make it a little bit sped up in that process. And here we'll get into some of the different joints and how they're effectively used. As I mentioned before, the butt joint is the most commonly used. And we'll start to get into sort of the different types of uses for dimensional lumber. So first, we'll want to talk about what is known as stock platforms. Now, stock platforms are basically meant to sort of last a very long time with very little maintenance. They usually have a pretty standard size that they are built in, which varies just a little, but is pretty uniform to most basic structures. And it's the last thing is that it's fairly rigid. Now, this is where we would want to use 2x4 as our construction type material. The reason for that is its overall strength and resistance to forces makes it an ideal choice when creating stock platforms. Now, while we could build some platforms out of 1x, it is not as structurally sound, which means that over time it would deteriorate a little faster than your 2x4 platforms. Here you have a wide range of selections of your typical type. They typically do not ever exceed 8 feet in length, simply due to the fact that a standard sheet good of plywood is 8 feet long by 4 feet wide. So that's why you'll typically build a lot of your stock platforms no greater than 4 foot wide by 8 foot tall. When you're also using plywood, you also want the thickest type due to, again, its sort of strength and resistance to forces. If you were to use 1/4 inch or 1/2 inch plywood as sort of the skin or the top layer for your frame, those sections in between the frames would be very brittle and weak. So over time, people stepping on them would basically cause it to crack, break, or punch holes through it. Versus 3/4 ply, which is the strongest type, allows pretty even dispersion of weight over a small distance. Now, the basic structure that we have here, we will cover, I'll blow it up here. So you have your overall height set at 8 feet. Your overall width then is 4 feet. This is, again, sort of where we'll get into sort of the measurements and getting sort of the basic structure down. Now, for platforms and walls, this is very similar structure. So the overall length is 8 feet and the overall width is 4 feet. Now, this is where we break down sort of the actual structure and the walls and platforms, even though they're different in sort of material type, they are both built very similarly. The top and bottom boards are known as the rails, and then your 2 vertical pieces there, or at least in this image, the 2 vertical pieces, are known as the stiles. All of the cross members that are in between are known as toggles. Now, typically in construction, or at least in theater, all of our toggles are usually about 2 foot offset from each other, and that gives you a pretty good dispersion of weight. We aren't as strict as commercial construction because we have sort of the ability to claim all of our structures as temporary versus permanent structures. If all of our things that we built were designated or meant to be permanent as permanent installations to the building, they would follow a much more rigid construction style. So this basic framework creates the overall platform base. Once you have all your plywood then attached to the top, you have your basic stock platform. Now, obviously, depending on the performance or the play that you're working on, these platforms may vary. But as long as you have some of these stock platforms available, it can help fill in a lot of the gaps versus having to custom build everything from scratch every single time. Now, while most platforms that we will be using or see in theater are mainly built out of lumber, there are other types of material that we could build from. Metal platforms can be the most sturdy and the most rigid simply because of sort of the stress and breaking strength of metal versus wood. It tends to bend less over a period of distance without being supported underneath, but they are a little more time consuming to build and require the use of welding tools in order to build them. Plywood can also be built or used to build your platforms. They can be substantially heavier due to the overall weight of plywood, but they can provide a pretty good and basic structure if you so need, or if some of the other materials aren't as readily available. While 2x4 is the most commonly used, we can also then see 2x6s, which are a little bit wider than 2x4s. They do again sort of create just a little bit more of a bulkier platform and slightly heavier than they would be, but they tend to have a little bit of a longer lifespan than your 2x4 frames. One of the other ways that you can build a platform is what is known as sort of a stress skin platform. Now, the difference between this particular platform and your standard stock platform is the overall size of them. Typically with stress skin platforms, they will be built only in a 4-foot by 4-foot square. So obviously you would have to build a lot of them in order to sort of fill out any sort of given space or theater house. The overall framing of it, though, does provide a lot more structure to it and longevity to the overall pieces. In order to build one of these, the internal or center framing piece is usually ripped down 2x4 to a much smaller length or width, sorry. And then instead of having a piece of 3/4 ply on top, you would use a 1/2-inch sheet of plywood on the top and then add a 1/4-inch sheet of plywood on the bottom. Now, one of the things that this does is, as you can see in this picture here, is in your sort of standard construction, if you put too much weight in the very center of any kind of platform or board, you're going to get a lot of bend or bowing that will occur. The premise behind the stress skin platform is the 2 sheets of plywood plus the wooden framing member in the center act as sort of a triple layer to prevent that sort of bowing from occurring. So over time, instead of getting something that may sort of get out of shape or bow, a stress skin platform should maintain its overall shape and structure. Now, while typically we'll be building or would build fairly square or rectangular shapes, you can sort of create some fairly irregular pieces just depending on what you need. Obviously, you would have to utilize some of the other tools to create some of these irregular cuts or shapes from the plywood itself. And as you can see here, you would have to add more framing on the inside to help ensure that the frame, not only along with the plywood, helps maintain the actual shape you want. One of the ways that we can sort of help or move around some of these platforms is if they were castered. Now, again, this sort of varies depending on what you need or what is available, but typically you can slap together a couple of these stock platforms to create a large structure such as this here. And what that would allow you to do is if you have sort of caster skates, sort of boards that already have casters attached to them, you can easily attach them anywhere on this platform piece, thus allowing you to sort of roll this unit on and off as needed. The casters in this particular image are what are known as sort of static or dumb casters, and they are referred as such because they only roll in one direction. They do not have the ability to swivel. So some of the circled wheels or casters that you see in this image are sort of redundant pieces, and that's mainly just because you don't need that many casters due to the fact that there's another caster in close proximity to it. Now, in order to sort of track these on and off, there's a couple different systems that can be implemented to allow you to track them quite evenly and ensure they stay on the path that they're supposed to. This first image here shows the wheel actually being surrounded on both sides to sort of help prevent it from veering off left or right. More often than not, you'll have what is known as sort of a guide plate, and that's usually a piece of metal that will be sort of pinched or wedged in between two pieces, and then that sort of help guides the overall unit from rolling off into a direction you don't want it to. And then this last image is sort of another variation of that same process. Circular platforms are great, depending on, again, your project. They're most commonly used in sort of a turntable type platform, and that basically allows you to sort of create a giant circle or donut in most cases, where the center of that sort of donut shape stays stationary, and the ring or the donut actually allows the ability to sort of turn around in a circular motion. Depending on what you need, though, again, you would utilize a lot of your stock platforms to sort of create the base of that structure, and then build some of the smaller pieces around it to help sort of finish it out. There are often times in which you will also want to create a raised platform or a raised deck. And the way you would do that is basically creating stud walls. This image here is a basic structure or layout for a 24 by 24 foot section. And these little 12-foot stud walls have been built and spaced out evenly to allow all your platforms to be laid on top of all of these stud walls. Basic construction of the stud wall is very similar to the structures themselves of sort of your stock pieces, but in this particular case, extra pieces of blocks are added, and they can be either out of half ply or 3/4 ply, depending on what is more readily available. And those basically help prevent the overall structure of that stud wall from basically crumbling under the weight of all of the platforms. You'll typically then want to use what is known as cross bracing. And this is where you can, again, still use 2x4, or you can go to 1x4 to create your cross bracing. Now, cross bracing basically allows you to attach multiple pieces, such as those stud walls, together, so they help sort of maintain staying completely vertical and allow them to not shift around due to the actors or the scene happening on top of them. Another function of sort of a platform is that you can create the raked stage that we talked about a few classes ago. And there are, again, sort of two methods to sort of create this. You can create these raked stage by adding singular legs at different mitered cuts along the bottom of your platform to sort of create that raked set. But more often than not, what that does is that it creates a little bit of unevenness, especially if your floor isn't completely level itself. One of the other things that could happen is, as you can see in this very first image, that the position of the leg has to be just right in order for it to sit properly. If you were to attach the leg without it being mitered, that pivot point there, whenever the weight whenever weight it would be put directly on that point where the leg is attached, it would easily be able to be bent and eventually broken. So what would typically happen is sort of you have this section here where your platforms are sort of spaced out again, and underneath you have a beveled stud wall, which allows the platforms to sit evenly on both sides of that stud wall, allowing you to give you that raked stage. As I mentioned before, there is a little bit of a sound dampening necessity in some cases of these sort of raised platforms. One of the things that happens is, as you can see in this image here, you have your basic plywood and framing at the bottom, and then you would have something that is known as sort of homosote, or your insulation, which sort of helps deaden a lot of that sort of clanking or clogging around that actors' shoes provide. And then you would typically top it off with a hardboard, such as that masonite or MDF. Again, sort of like the orientation of OSB, you kind of want to have it sort of alternating directions. And one of the reasons for this is that in the end, this alternating pattern allows you to sort of hide the seams from below or the other piece below. This is important because it's not always 100% accurate whenever you put two platforms together. There may be a gap or something. Excuse me. There may be a gap or something that is out of your control to fix. And so having these alternating layers allows you to sort of hide those as best as possible. And now we get to some of the various ways to attach said platforms together. Depending on what type of raised platform you're working with or what kind of structure you're working on, the easiest to do would be either a combination or one or the other, known as either through bolt, in which you put both platforms side by side, make sure they are level, and then you drill a hole through both of them, and then you put a bolt and then secure that together. That is one of the easiest ways to do it, and it's also one of the most secure ways of doing this because the through bolt typically has a greater breaking strength than any other fastener that we can come across. The absolute fastest way, and usually can be something as a temporary hold, would be using screws. You'll typically want to use fairly long, sort of beefier screws, depending on if you have the availability of them. They can be a little faster to put in than bolts, but they definitely are not as strong. The last is what is known as sort of a coffin lock. There's a couple different variations, but this image here shows one of the more commonly seen, and it basically has two connecting pieces. So one piece will be attached to one platform, and then the other piece will be attached to a second platform. Now, you'll obviously have to have those pieces alternating again, and there's usually a system set up. I might have an image to show you. If not, we'll just remain on this. And basically, in the one image, it basically has a hook, and that hook is controlled by that center hole in which you take an Allen key of the appropriate size, slot that in, and then rotate that hook. And that hook should spin and grab that second platform as long as it has the corresponding piece. And then what would happen is those two pieces then sort of lock together or pull together and then lock together. This particular method is extremely time consuming, but in the end, as long as all of your pieces have, or all of your platforms have been built the same way, it can make the overall load-in process or the installation process significantly faster than having to deal with trying to work with through bolts and or screws. And next we have flats or walls. Now there's two distinct types that we mainly see in theater. Those are known as Hollywood or Broadway. They get their names respectively for sort of the area that uses the most and sort of just the design better suits one or the other. The Hollywood flat is when the framing is on edge. That means you see the short, small side, the 3/4 inch most likely. And it is better suited when units can be secured to the ground. They provide a little bit of depth to the overall project, and they sort of help sort of fill out a little bit more of the space. The Broadway flat is when the framing is on its face, so you see the wider part of the structure. And the reason for this is that it reduces the overall footprint that is caused, and it makes it ideal for sort of the flown scenery that we can sometimes use in theater. The other reason for its sort of small size or build is due to the fact that the fly space is usually fairly limited in space. So having them as thin as possible allows the units to be able to fly in and out efficiently without running into anything such as sort of other units or especially any of the lighting instruments that may be flown overhead. One of the key differences between the two is that the Hollywood flat utilizes a lot of the joints a little more effectively, which allows them to be stapled and glued together to sort of help hold it all in its shape. The Broadway flat, however, as we see here, is flat enough, but it doesn't provide the necessary joint capabilities as the Hollywood. So you would have to utilize these other little key features known as the corner block, the corner braces, the keystones, or straps. Basically what these pieces do is they sort of span or cross over all of the joints that exist and allow you to sort of secure those pieces into those joints of each corresponding piece of the frame and just help secure everything together. The corner blocks, as you can sort of see, are shaped like a little extra corner. The keystones and strap basically just sort of straddle most of your interior joints, just sort of to help maintain the overall structure. You'll notice, however, also in this picture that there is a slight gap around the edge of the frame. The reason for this is there are often times in which you can have multiple Broadway style flats in conjunction or next to one another. So every time that you build one, you want to ensure that there's at least a 3/4 of an inch gap around each one. That allows the framing of one to actually butt up and create a perfect corner or almost seamless corner. As you can see here, this is basically how one would go about constructing one of these flats. You would typically start in one of the corners, attaching one of your stiles to the rail, and then you would typically add the other stile, and then lastly you would add the last rail on top. It's important to sort of get the overall outer frame done first, as it'll make the interior or toggles significantly easier to sort of make sure that they are going in the right place. This is also where some of the defects come into play, though. There are often times in which utilizing 1x4, which is often best for these walls as it keeps them fairly lightweight and easy to work with, you get a lot of the bows and or bends in the wood, as you see here in this picture here. Now, this basically shows what sort of not to do and what ultimately to do. If you have both of the pieces bowing in the same direction, the overall shape is going to bow out in that same direction. If you have both of your stiles going in opposite directions, it would make it significantly harder to attach your interior toggles unless you get the help of either a friend or clamps. The ideal situation is to have both of the bows facing in towards the middle of your frame. The reason for this is once you get to adding the toggles are actually going to push all of those pieces out to the actual width that you want ultimately. And that just makes sure that everything stays exactly where you want it. Once again, we then get to sort of the addition of your skin or the face of the project. And it's important to make sure that all of those joints are secured in such a way, because as you can see here, just a little bit of force from one corner can topple the entire thing. But the addition of just one corner block will make sure that the entire frame is that much secure. The face or the skin of the project is usually Luan in most cases when it comes to walls. This is again because it's a fairly lightweight material and it's easy to work with and attach to the project, as it is a little more brittle and a little more malleable than plywood. It also has that fairly nice finish, as we talked about earlier. So whenever you get to painting or anything else to do the finish work, you get a pretty good look, versus if you try to attach plywood to the face of these walls, you would sometimes get the defects that you would see in plywood. When you're attaching the face, it is typically advised to again sort of start in one corner like you would do the actual framing of the project. And from there, you work the short side first. And as you sort of go along, you line up the edge of the Luan with the edge of the frame. This ensures that it stays nice and flat and flush for when you actually stand it upright, that there isn't anything causing it to sort of bend or be pushed in one direction or the other. Once you get that short side done, you then go back to that starting or first corner and then work up the long side. Again, sort of as you go through, you want to make sure that the edge of the Luan or your skin is also flush with the outer frame. The reason you would do this is oftentimes whenever you build a frame, it may not stay completely square from when you first started to build it. Ensuring that the edges line up perfectly should ensure that the overall structure or the frame will be pushed or forced into its square position. Once you get that long side done, you can then go and start working on the other two sides. You also want to make sure that if you have any toggles on the interior portion, that you staple those in as well as you go along to ensure that no bubbles are being formed as you're stapling everything together. There are often times in which you build a wall or a unit that may exceed the 8 foot mark or measurement of most sheet goods. While we typically don't do this for stage platforms, walls, however, are a little easier to work with. So what you would do is at the 8 foot mark, you would add what is known as sort of a little catch plate, and that is where a small piece of 1x or other material is laid on its edge to provide more surface area for 2 pieces of luan to actually be attached to. As I mentioned before, some of the ways that the walls can be oriented, as shown here, would be how those Broadway walls were built. So having that extra 3/4 of an inch gap on each edge allows all of these walls to sort of create these nice corners. This was one of the original ways in which all of these corners would be attached and sort of held together versus using screws or other fasteners. This was known as sort of lashing, and little hooks would be attached to one side or the other, and a rope or string would basically be sort of dragged from left to right, catching all of these hooks, and then eventually tied off near the bottom. This would ensure that the gap would remain as small as possible, or provide you with that, again, very flush and clean looking corner. Some of the other ways the walls can be attached is if you lay out all of the frames, such as this picture here. And this picture has the frame of multiple pieces being built, and then all of your luan or your facing is then attached afterwards. Now, one of the reasons why you would do this is it would help sort of provide a much cleaner looking build versus building each of these walls or section individually, and then having all of those gaps sort of show up in the end. May not be as efficient, but depending on the overall size and space of your scene shop or the stage space itself, the finished product is always going to take more precedence than the ease of construction sometimes. There are some times, though, in which a unit may have a hinge piece in the middle, and this may just be for sort of transportation purposes. But once you get to the sort of final staging place, you can add what is known as a Dutchman to cover one of those joints, as you can see in this middle section here. And basically what that Dutchman is a small piece of fabric or a thin piece of material, and it basically just goes right over the seam and sometimes those hinges, and it sort of disperses or sort of breaks up that sort of hard looking edge and allows you to sort of then paint over that Dutchman to sort of touch up any of the color of the wall itself. On the back side, to ensure that the walls sort of stay exactly where they are, you would add what is known as a stiffening batten. And this batten basically just stretches from one side to the other and provides a nice flat surface for that piece to sort of ensure that it stays nice and flat on all sides. There are times, though, in which your project may not have what is known as sort of the hard cover. We can often sometimes add what is known as a soft covered wall or unit, and it has sort of the same principle as sort of the hard covered flat. You would size everything to make sure that you have enough fabric, such as this first picture here, to cut a little bit of extra space to make sure that you can wrap around the edges of the material. Instead of starting in the corners, however, to attach everything, you would typically start in the middle. And this is basically to ensure that as you sort of work towards your outer edges, that everything is stretched nice and tight so you don't have any wrinkles show up in the fabric once you are finished. That pretty much sums up everything for today's lesson. As I mentioned before, I will try to upload a couple videos, probably just links to YouTube, to some of my own little personal favorites, little montages, mainly of just sort of do-it-yourselfers that have posted online. And this is to sort of show and utilize a little bit of your time to sort of see how some of these things are actually accomplished. If so, or mentioned or offered, if you would like sort of a personal demonstration on some of these effects and or have a demonstration, I could probably set something up to sort of provide a little bit better knowledge as opposed to just talking about them. But as always, if you have any questions, comments, or concerns, you can always email me. Or if you need to, you can start a discussion in the discussion page and see what your fellow students have to offer as a form of answer, or I can chime in as well.